Hello, my ninja warriors. Yes. So finally, we are going to discuss telescopic series. I will not restrict this session to telescopic series because this session is going to cover all possible types of series which is there in your sequence and series syllabus. Okay. So series special also you can call, and the moment you enter the session, you know that you have to smash that like button. And if you are coming to my session for the very first time, or if you are coming to this channel for the very first time, this is my brief introduction. My name is Namrata and I have over more than 10 years of teaching experience in both online and offline. These are my credentials. And before I start, let me remind you about MVSAT examination over here. So it is happening on 4th, 5th, 11th and 12th October, and the last date to register. Let me not talk about the last date of registration because I want you all to register as soon as possible because it is absolutely free, and on top of it you are going to get a detailed performance report of yours which will tell you your weak areas and strong areas as well, which is going to eventually help you in your upcoming competitive examinations, right? Okay. Yes. So, why so much of less crowd today? I don't know why. Anyway, chalo, let's start with type 1. Let's start with type 1 series. Type 1 type of a series. So for that, I will tell you a couple of formulas which you have to keep in mind. So this is going to be sigma 1. That means 1 plus 1 plus 1. How many times? Plus 1. How many times? N times. So n times, if you are going to add 1, you are going to get n. This is the very first thing or very first formula in the world of series. Hi Ragul, how are you? Then the next one is going to be sigma n. Sigma n is nothing but 1 plus 2 plus 3 plus 4 and all the way up to n, which is nothing but n plus 1 by 2. Okay. So this is sigma n, 1 plus 2 plus 3 plus 4 and all the way up to n, correct? You have to keep in mind, you have to by the way, I will ask you one direct question. Tell me, sigma n, right? So over here, just tell me sum of first 10 natural numbers. So ma'am, it is going to be 10 into 10 plus 1, that is 11. 10 into 11 by 2, so 55. Okay, and some of first 100 natural numbers you have to keep in mind. That's how we started this particular lecture. That is going to be what? 5050. Good evening, Prithija. Good evening. Okay. All right. So this and this is sigma n square. Sigma n square is 1 square plus 2 square plus 3 square and all the way up to n square. Tell me, n plus 1, 2n plus 1 by 6. This is the formula you have to remember. And sigma n cube, which is what? 1 cube plus 2 cube plus 3 cube and all the way up to n cube. Okay. Yes. Hi Sai Priya, how are you? This is n plus 1 by 2 whole square. By heart these formulas. By heart these formulas. And haters are going to come in on this session and tell you that, oh, this part is deleted, this portion is deleted. But you know what? NTA, this is actually a history. This is a ritual. The moment NTA comes and announces, oh, hello, this topic is going to be deleted. This topic we are going to not give in 2025 or 2026. Just go and check that topic. That means those are must-to-do topics. NTA deletes it and you have to compulsorily study that topic. Okay. Yes. So this is one such topic which you cannot ignore. All right. Okay. Yes. And let me just open the chat box over here. Okay, so now let us solve this particular problem. Okay, so yes, hi Taruna. Okay, I'll call you Preeti is much easier name for me. So yes, better name, thank you. All right, now let's start. Find the values of positive integer n for which the quadratic equation has solution alpha and alpha plus 1 for some value of alpha. Very interesting and very good question, I would say. And if you go and check, this was not exactly the same. This is a replica of PYQ, or you can say that one PYQ was asked on the basis of this particular question. Let's understand. Find the values of positive integer n. Okay. So over here, it looks like that it is a quadratic equation, right? So what we are going to do is, sigma I am going to keep it outside, k is equals to 1 to n, and I am going to multiply this. So this is going to be x square, then it is going to be k square minus k times x, and this is going to be, sorry, this is 2k minus 1, 2k minus 1, 2k minus 1 plus 2k minus 1x plus k square minus k is equals to 10n. This is your quadratic equation now. Yes, we have just started, Abhijit. You have to like just watch it from the beginning. Okay, you will get to know whether you are late or not. I mean, why do you ask? You know the class has been started, so obviously you are late. How many minutes? That you will see, na? In YouTube there is a feature, started streaming 7 minutes ago. So yes, you are 7 minutes late. Okay. Chalo. Now this sigma x square plus, okay, so I have just simply multiplied it. How to solve it? We have to solve this particular thing. Okay, so now sigma is outside, k is equals to 1. I am going to multiply this sigma inside. Okay, let's do it. So this is sigma of x square plus sigma of 2k minus 1x plus sigma of k square minus k. Okay. And sigma starts from k is equals to 1 to n. This is also k is equals to 1 to n. K is equals to 1 to n. Okay, right? Is nothing but 10n. Now, understand this sigma over here. Sigma can be multiplied. Okay, so in here what we have seen is sigma can be multiplied. But you know what? Sigma will only be relevant when there is a k. Okay, so this x square has no effect of sigma. Basically what they are saying is, keep on adding x square how many times? Keep on adding x square how many times? N times. So what are you going to get? Ma'am, nx square. Yes or no? Tell me. Yes? Clear? Now, what is this? Open the sigma k is equals to 1 to n. Correct? So if you put k is equals to 1, what you're going to get is, ma'am, if I put k is equals to 1, so this is 1. If you put k is equals to 2, so ma'am, 2 2s are 4 minus 1, so 1 plus 3 plus 5 and so on all the way up to n. Outside this there is an x. Correct? Okay, plus. What about this? Sigma will get multiplied. So this is sigma k square minus sigma k is equals to 10n. K is equals to 1 to n. K is equals to 1 to n. Getting it? Understanding it? 1 plus 3 plus 5. Now this is what? Summation of n terms of an AP. Correct? So plus nx square we have got plus 1 plus 3 plus 5 and all the way up to n. This is x plus sigma k square minus sigma k is equals to 10n. Okay, n is equals to 1 to, sorry, k is equals to 1 to n. Then k is equals to 1 to n. Okay, n x square plus. Now what is this? Can you see? This is n terms. Okay, last term is actually not n, it is 2n minus 1. How many terms? See, if I go back now, how many terms? N terms. Why n terms? Because see, the moment you put k is equals to 1, you will get 1. K is equals to 2, 3. K is equals to 3. Then 5. K is equals to 4 and so on. Last you have to put k is equals to n, 2n minus 1. Total n terms are there. Okay, by the way, there is a direct shortcut for it. Direct shortcut says sum of first n odd natural numbers. Odd natural numbers. Sum of first n odd natural numbers is nothing but n square. So this is nothing but n square x plus. Now sigma k square, I just taught you this. I literally just taught you this. Let me go back. Sigma n square. Sigma k square and sigma n square are exactly same. So the formula is n plus 1. 2n plus 1 by 6. Let's put this formula. So sigma k square will be n plus 1, 2n plus 1 by 6 minus sigma k is nothing but sigma n. What is the formula? Sigma n is n plus 1 by 2 and this is equal to 10n. This is equal to 10n. Okay, now understand. Can you see from left hand side and right hand side, we can cancel out n. N is gone, n is gone, n is gone, n is gone, n is gone. Okay, and you know what? If you take LCM, what you're going to get is 6x square plus 6nx plus, this is n plus 1, 2n plus 1 minus n plus 1, 3 times n plus 1 in fact. If you take LCM, no? 3 times n plus 1 minus, now this is what? 60 is equals to 0. We just need to solve this. This is a quadratic equation, right? Okay, all right. So this is a constant term. If you can see, this is a constant term. Correct? Okay. This is a constant term. Minus 60 is also there. Okay. Or in fact, okay, let me go back, let me read the question. Has solution alpha and alpha plus 1? Can you see this quadratic equation has solution alpha and alpha plus 1? You know what? I don't want to do this. Let me just keep the coefficient of x square. I want to keep as 1. So x square plus nx plus. Now what about this? Let me take n plus 1 by 2 common. So that 2n plus 1 by 3 minus 1 is right here is equals to 10. Okay. So this is going to give you x square plus nx plus this is n plus 1 by 2 is common. And this is what? 2n plus 1 minus 3. So 2n minus 2. So 2n minus 2 is 2 times n minus 1 upon 3 and is equals to 10. Can you see this 2 and 2 is cancelled? So over here what you're going to see is x square plus nx plus this is what? Again n plus 1 into n minus 1. So n square minus 1 upon 3 minus 10 is equals to 0. Okay. Now I think it is pretty much easy to solve. X square plus nx plus n square minus 31 by 3 is equals to 0. Correct? Okay. Now this is your quadratic equation. Let me rewrite this quadratic equation. X square plus nx plus n square minus 31 upon 3 is equals to 0. Now this quadratic equation has two roots, alpha and alpha plus 1. Yes, alpha and alpha plus 1. Just tell me one thing. Difference of roots. Difference of roots is what? Ma'am, difference of root is equals to mod alpha minus beta is nothing but what? Tell me. Root d by a. Mod a. So root d by a in this case. So here difference of roots is clearly 1, which is nothing but root of d, discriminant b square, minus 4 ac upon a is anyway 1. Okay. So now we just have to solve it. So this is 3n square. 1 is equals to b square minus 4ac. Correct, na? Square root of 3n square minus 4n square. This is 31, right? Plus 4 and 124. Okay. So what you're going to get is 124 minus n square should be equals to 1. Okay. So n square is what? Am I doing anything wrong? 4 3s are 12. Okay. And 4 3s are 12. 124. Is equals to 3 actually, na? 3 root is equals to 9. Kya? Hold on. Square root. Okay. Yes. Now this is equals to 3 is equals to what? 124 minus n square. Now it's absolutely correct. So from here, n square is equals to 121. So n is nothing but 11, my dear students. 11. And you know what? I'm not kidding. This is a JEE Main PYQ. JEE Main PYQ. Okay. See, I think sequence and series was limitedly used, but this is a clear-cut question of sequence and series and quadratic equation. Still, how many lectures are there? After this lecture, one more lecture that will cover AM, GM, HM inequality. Today, all series will done and dust. Okay. So yes, see, let me just conclude the question. Very good question, by the way. Find the value of positive integer n for which the quadratic equation has solutions alpha and alpha plus 1. From here, we realize that difference of roots is 1, which is a known quantity. Okay. And this was the question. Now we realize that, okay, first of all, let me just multiply this. If you multiply x square, okay, and then k minus 1 plus k will be 2k minus 1 x plus product of these two is k square minus k. On the right hand side, 10n sigma free 10n is right here. Okay. So we are going to understand the left hand side. Multiply sigma to each and every term. So sigma x square, sigma this term and sigma this term as well. Now sigma x square, that means you have to add x square how many times? N times. So that is why nx square. Okay. Now what is this? So this is, if you put k is equals to 1, you're going to get 1. 1 plus 3 plus 5 and how many terms? So total sigma starts from k is equals to 1 to n. So n terms. Sum of first n odd natural number is nothing but n square. So this thing will be replaced by n square. So nx square plus n square x plus now this is sigma k square minus sigma k. So sigma k square will be what? nn plus 1 to n plus 1 by 6. Sigma k will be nn plus 1 by 2 over here. So just put the value. Okay, this is n square. This is nn plus 1 by 2 and this one is nn plus 1 to n plus 1 by 6. I can clearly see, and on the right hand side 10n is already there. I can clearly see that 1n is getting cancelled out from both the sides. Correct or not? Yes. So now x square plus nx. Now let me just solve this out. N plus 1, n plus 1 can be taken common and 1 by 2 also can be taken common. So n plus 2n plus 1 by 3 minus 1 is equals to 10. Now solve this out. If you solve this now, 2 will get cancelled out and this is what you're going to get. Eventually, just sort the constant part out. You are going to get this. This is your final quadratic equation. And remember, so this is just a solving part, nothing major. But now quadratic equation concept comes into the picture that roots of this quadratic have a difference of 1 because 1 is alpha plus 1 is alpha. So difference is 1, right? Okay. So over here, if you subtract alpha and alpha plus 1, what are you going to get? You are going to get just 1. So 1. And the formula of difference of roots, tell me. Root D by A, ma'am. Root D by A. Okay, so root D. So root D is this, upon A is equals to 1. Just apply this, remove this square root, apply a square over here. So 124 minus n square is equals to 3. So n is equals to plus minus 11. Negative 11 I will obviously reject, because of obvious reason. N can never be negative because it is given in the question only, no? That positive integer n. So n is 11. Getting it? Understanding it? Chalo. Ma'am, nx square no, but x square how come? Arey, I cancelled it, no? I cancelled it. Don't you see that nx square? Can you see I cancelled it? Each term is having one n. So if each term in throughout the equation having an n, I can take common and cancel. So here this is the n, this n square. So one n is gone, so one n is left. This is also n, this is also n, and on the right hand side this is 10n. So that's how one n got cancelled. So eventually x square plus nx plus the remaining things. Okay? Yes, Anjali? Alrighty, getting it? Okay. Now the next question. This. Compute the sum 31 square plus 32 square plus 33 square plus 30. You know what? We can actually calculate. We know the formula, right? 1 square plus 2 square. Ma'am, you have told us 3 square all the way up to n square. So if at all n is 50, so it is going to be 50. Okay? Correct? Now this, which you can see over here, is nothing but sigma n square, which is n plus 1 to n plus 1 by 6. So this is 50 plus 1 to n plus 1. So 101 by 6. Okay? Minus. See, because you don't want first 30 squares. So subtract 1 square plus 2 square plus 3 square, right? All the way up to 30 square. So those 30 squares will get cancelled out, and 31 square, 32 square will be remaining. Yes, that's the agenda. Can we do that? Because we know the formula from the beginning. We don't know the formula from the middle. So I started with 1 to 50 and subtract first 30 numbers. Okay. So minus, now again, sigma n square, n is 30, then n plus 1, 31, then 2n plus 1, so 61 upon 6. Okay. So what you're going to get is 1 by 6 if you take common, 10 by 6 in fact. Okay. So this is 5 into 51 into 101 minus 3 into 31 into 61. If you do the calculation, what are you going to get? I'm not doing it, okay? 33470, anonymous is saying, so 33470. Okay? Yes? Clear? All right. Yes. And see, you can still 3 2s are 6, 3 1s are 3, 3 7s are 21, 3, this is also 3 1s are 3. So that's how it is. Now just keep on solving, you will get the answer. Okay, easy question. Now what about this? What about this? This category. Okay, so this is again another type of series wherein you can first of all write the general term. So there are certain steps. Step number 1, write general term and apply sigma. Write general term. Step 2, apply sigma. Write general term and apply sigma. Okay. Samina, have you attended the previous lectures? Have you attended previous lectures of sequence and series? Because then it will be a trouble, Samina. So today is actually third lecture of sequence and series, right? So all I can say is, Samina, go and watch first 3 lectures and then come back. Okay, otherwise, and also you have just joined. You have just joined. Samina, what you do is you just randomly join a session, okay? And you expect, you were not there since the beginning. Yes, Anjali also joined today, but maybe you have studied sequence and series little bit earlier, okay? Otherwise, you know what? These questions are very basic questions. These questions are very basic questions, okay? Not very difficult. You should understand this. And we have just started this topic. So if basics of sequence and series is clear, I don't think so there must be any trouble in understanding these basic questions. Okay. See, apply sigma. है ना? So write general term. So first of all, tell me what is the general term. Tell me. So ma'am, general term Tn. See, general term will be what? Tn. Ma'am, 1, 2, 3. The first term is 1, second. So this is first. This is your second. Second term is 2, 3. So it start with 1, 2, 3. So n plus 1 and n plus 2. Like that. Alright. Yes. Tn is equals to what? Is it n plus 1, n plus 2, n plus 3 whole upon 4? Where are you getting 4 from? Okay. So Tn is n plus 1, n plus 2. So Tn finally you get, multiply. So ma'am, it is going to be n, and this is n square plus 3n plus 2. So Tn is going to give you what? N cube plus 3n square plus 2n. Okay. Alright. Now, sigma Tn. Apply sigma. Sn is equals to sigma Tn. Okay. Sigma Tn is what? Sigma n cube plus sigma 3n plus sigma 2n. Okay. So this is going to give you sigma n cube. Tell me. Sum to n terms, right? Sigma n cube. Ma'am, n plus 1 by 2 whole square plus 3 sigma n. 3 will come out. So 3. Now sigma n will be what? n plus 1 by 2 plus sigma 2n. 2 if you take it out. So sorry. This is n square, right? Oops. So this is sigma n square. Sigma n square is n plus 1. 2n plus 1 by 6. And this is 2 sigma n. Okay. Sigma n is what? n plus 1 by 2. Okay. 2 cancel. 3 ones are, 3 twos are. So this is how it is. And now this is your Sn. Now I can clearly see that n plus 1 you can take it out. So Sn is going to be n plus 1. Okay. So n plus 1. Now n plus 1 by 4 will be staying inside. So n plus 1 by 4 plus. Okay. This is n plus 1 by n plus 1 is already gone. So 2n plus 1 by 2. So 2n plus 1 by 2 plus. Okay. Plus 1. Alrighty. Yes. So Sn is going to be what? n plus 1 will stay outside. Now this is n square plus n plus, take LCM 4, plus 4n plus 2n plus 4. Okay. Sn is going to be n plus 1. So this is n square plus 4, 5, 6, 7n plus 4 whole upon 4. This is your sum of n terms. Correct? Sum of n terms. Hold on. Plus 4. 4n plus. Hold on. This is n square plus n. Now this is 4n plus 2. 4n plus 2. This is 2, right? 2 plus 4. This is 2 plus 4. So this is, yes, 5n plus 6. So this is n plus 1. Now this is n plus 2, n plus 3 whole upon 4 is the final answer. Yes? Okay. Sigma Express is already started. Okay. When they will end, so by the November end we'll finish the syllabus, and after, like in December, most probably December, January, revision will get started. Okay. And once you enroll, you will get the detailed material. Okay. Yes. Now this, the sum of the series, this is type 1 only, where you have to write the general term, apply sigma to it. Okay, ma'am. So first step number 1, write general term. Can you tell me general term? So ma'am, in first term it is 1 square. Second term, this is 1 square plus 2 square. Third term, 1 square, 2 square, 3 square. So now nth term will have what? Nth term will have 1 square plus 2 square plus 3 square plus n square whole upon. First term denominator is 1, second term denominator 1 plus 2, third term denominator 1 plus 2 plus 3. So this is 1 plus 2 plus 3 all the way up to n. Okay. So now this is actually sigma n square whole upon sigma n. Yes or no? You know the formula, right? You know the formula. n plus 1, 2n plus 1 by 6 whole upon, this is n plus 1 by 2. Now start cancelling. n gone, n plus 1 gone, 2 1s are 2 3s are. So Tn is going to be what? 2n plus 1 by 3. And now, you know what? Whenever you are in self-doubt in such questions, now, what you can do is you can check. Tell me what is term number 1. Ma'am, term number 1 will be what? 2 into 1, 2. 2 plus 1, 3 by 3. Ma'am, term 1, T1 is coming out as 3 from this formula. What is actual thing? So, ma'am, T1 is 1 only. T1 is 1 from here, 1 from here. T1 matching. Ma'am, T2. T2, ma'am, T2 from here, 2 2s are 4 plus 1, 5. 5 by 3 is your T2. Right? So, from here, 4 plus 1, 5, 5 by 3. 5 by 3. Okay, T2. T3. T3 is going to be what? 7 by 3. From here, ma'am, it is going to be 9 plus 1, 10, 10, 14 by 3, 4, 5, 6. 14 by 6, ma'am, 7 by 3. Oh, every term is matching. Every term is matching. Okay, now, Tn is right there. Sigma Tn is going to give you Sn. So, sigma Tn is sigma 2n plus sigma 1 upon 3. Sigma 2n is what? 2 times sigma n. 2 times sigma n. So, 2 times sigma n is, ma'am, 2 times n plus 1 by 2. Plus sigma 1 is n whole upon 3, 2 to cancel. So, this is going to give you what? N if you take common. N if you take common, so n plus 2 by 3. This is your Sn. Now, S31, if somebody asks you S31, because as per the question they are asking 31. So, 31 plus 33 by 3. So, this is 11. So, 341 is nothing but S31. Have a look. Let me know. 341. Yes, 341. Alright. So, let me go back and let me tell you that what did we study till now. Till now, we have studied that these are the various things, sigma 1, sigma n square, sigma n cube, and also one more shortcut we have studied, that 1 plus 3 plus 5 plus all the way up to n terms. Up to n terms is nothing but n square. Very important. So, based on these formulas, ma'am, today I have joined Express, it is showing it will start from September 6. Yes, pro player. Because till September 6, now some other chapters are going on. So, understand, we'll finish that chapter, then we'll take you from the fresh chapters, and whatever chapter you have missed, will give you either recordings or will basically will provide you with those chapters. Okay. See, because you have to understand that now already September is there. September, October, November, we have only 3 months. 3 months is very critical. Like we have to finish the chapters and revision also we have to do. Okay, and you have limited bandwidth. We can't keep on teaching you for 12-24 hours. Okay, yes, so you have to understand it is going to start from September 6th only, because currently I am in the middle of the chapter and I can't take you. If I'm going to take you from the 6th, 7th lecture, you won't be able to understand. Just like a couple of people are joining in and they are not understanding because they are in the middle of the lecture. Fresh lecture mein you will get that confidence. Okay, so yes, these are the questions that we have done. Now type number 2, using method of difference, very important for JEE Main. Very important for JEE Main. Okay, very important for JEE Main. What is this method? Let us understand. So I mean directly I'll tell you what kind of problems you will face, then you will understand that what kind of problems you will get. So find the sum of the series. Can you see 6, 13, 22? I'll pick one question. 6 plus 13 plus 22 plus 33 and all the way up to n terms. Okay, all the way up to n terms. This is what you have to figure out. And what is the series thing? What is the thing over here? Using method of difference. First of all, ma'am, what is so special about this series and why exactly this question you want to do with the method of difference? Who will tell me that okay, method of difference is going to work? See, understand. If I talk about method of difference now, 6 and 13, tell me what's the difference, just roughly. So I have 6 and 13 difference. What kind of series I am trying to understand? So 6, 7, ma'am, 7. So plus 7. And now 13 and 22, ma'am, 9. So plus 9. Then 11. Can you see clearly that this is not an AP, but the difference, 13 minus 6, the difference, 7, 9, 11, the difference is AP. The difference is in AP. Difference in AP. Okay, difference is in arithmetic progression. Okay, so difference is in AP or GP. If difference is forming any progression, then there is a fixed method that we call it as methods of difference. Okay, now understand methods of difference. How to solve such questions? Okay, let me erase this a bit. Let me write it here. Okay, this is plus 7, plus 7, plus 9, plus 11 and so on. Okay, so now S is going to be method of difference. Yes, pro player, yes, absolutely. From September 6, you will have the access of live classes and within a week, you will get the access of everything. Okay, pro player, it will take one more week for every access, but for live lectures, you will get the access of from 6th September. Don't worry about it. Okay, S is equals to. Okay, see, understand. You have to write Tn over here. 6, 13, 22, 33 and this is what? Tn. Tn. Okay, Tn. Alright, now S is equals to, now you have to write the same equation but in a slightly different manner. 6 will not be written over here. 6 will be written over here. 6, 13, 22 and all the way up to, see again Tn will be written over here because what we have done is the whole series we have shifted one step ahead. Okay, now what you have to do is you have to subtract method of difference. So whenever you find a series which is not AP, not GP, but the difference is in AP or GP, this is the method you have to follow. Write the first step S and the same thing you have to write but one step ahead. Now subtract. S minus S 0 is equals to 6 minus 0 is 6 plus 13 minus 6. Now tell me 13 minus 6, ma'am, 7, 22 minus 9, ma'am, 11 and so on and now till here. Now what is this? 0 minus Tn. So this is minus Tn. Okay, but you have to now help me with the counting. How many terms are there? First of all, ma'am, one thing we are seeing that 7, 9, 11, this is becoming an arithmetic progression, but AP of how many terms? That's the concern, because sum of arithmetic progression I can see, but how many terms? Okay, ma'am, let us figure it out. So, ma'am, if you start from 6, then 13, 22, 33, till here, right before Tn, till here. Ma'am, till here, so starting from here, let me write, starting from here till here, ma'am, n terms. N terms. If you remove the 6, because 6 is not the part of AP, right? 6 is not the part of AP, right? So it is going to give you what? See, till from here till here, n terms. But if you remove 6, how many terms? So this is AP of n minus 1 terms. Okay. So now 0 is equals to 6 plus 7 plus 11, 7 plus 9 plus 11, right? 7 plus 9 plus 11 up to n minus 1 terms and minus Tn. Tn will come here, so Tn will be 6 plus sum of n minus term of AP, correct? So sum of n minus terms of an AP, tell me. So ma'am, sum of n terms is what? N by 2, 2a plus n minus 1d. Okay, so this is going to be n minus 1 term, so n minus 1 by 2, 14 plus n minus 2, d is 2, okay. 2 ones are 2, yes 7 and 2 is gone. So Tn, tell me, 6 plus n minus 1, 7 minus 2, so 5 plus n, that's it. Okay, getting it? Understanding it? Alrighty. So Tn is this. Correcto? And you know what? I told you, if at all you feel like, ma'am, let's check T1. Tell me, if you, the moment you put n is equals to 1, you're going to get 6. So T1 is 6. Now T2 is 13, right? So put n is equals to 2 just to check whether your calculation, your concept is correct or not. T2 should be 13. So ma'am, the moment you put 2 now, 7 into 1, 7 into 1, 7 plus 6 is what? 13. So T2 is also correct. T3 will also fall into the place. That means Tn is this. Now the moment you have Tn, na, in fact Tn will be what? N square plus 4n minus 5, so plus 1. Okay, this is your Tn if you multiply. Sigma Tn is sigma n square plus 4 sigma n plus sigma 1 is equals to Sn. Sn is equals to what? N plus 1, 2n plus 1 by 6 plus 4 sigma n. So 2n n plus 1 plus n. Okay, and yes, sum of the series up to n terms. So this is the sum. This is the final sum. Okay, have a look. Let me know. Ma'am, why are we using, this is not telescopic, Harshan. Who told you this is telescopic? This is method of differences. This is method of differences. Okay. So whenever, Harshan, whenever you see that, okay, some series is getting formed, obviously you will check the series. The first instinct, oh, is this an AP? Is this an GP? Yes or no? You will try to find out whether it is an AP and GP. How will you find out? By understanding the difference, that 6 and 13. Either difference or what is the multiplication over here. So ma'am, the difference is 7, 9, 11. So now you understood that difference is forming a series. This series is not any series, but difference is forming a series. So for this, we will method of difference. This is very important for JEE Main. Now S, how to use it? Just write S is equals to 6 plus 13, 22, 33 and so on all the way up to Tn, correct? And now what you will do is again same equation but one step ahead you have to write and subtract it. If you are going to subtract it now, then what will happen? Tn will get isolated automatically, okay? And in here one term will always get wasted and eventually you will get an AP of n minus 1 terms or GP. Depends that the difference is in AP or GP. If difference is in AP, just like this, so you will get a sum of AP of n minus 1 terms over here. One term will be wasted and over here Tn will also get isolated. This is the same thing you are going to repeat in everything. Then it is first order. Then it is first order difference, ma'am. Yes, first order, usually first order only you will get in JEE Main. Now Tn will go there because you want Tn, right? Tn is equals to 6 plus sum of n minus terms of arithmetic progression. Apply the formula, you will get Tn. Once you get Tn, what do you do? Normal. Apply sigma to get Sn. Okay. Alright, now 5, 7, 13. Second thing, 5, 7, 13. Okay. So S is equals to 5, 7, 13. Okay. 5, 7, 13, 31, 85. Plus 85 plus all the way up to n terms. First of all, let us understand that difference is creating what? So ma'am, 2 is the difference, 7 and 13. So ma'am, 6 and this is going to become 7 plus 10. So 18. Then it is going to be 54. Okay, so I can clearly see now difference is in geometric progression. Can you see 2, 6, 18, 54? Can you see 2, 6, 18, 54? This is a geometric progression, right? You have to multiply 3, then 3, then 3. So difference is in geometric progression, difference in GP. So I can do a what do we say? What do we do actually? When we say that astrology, no? Prediction, I can predict that eventually I am going to get sum of n minus 1 terms of geometric progression. My last step would be sum of n minus 1 terms of geometric progression. Now let's see. S is equals to 5 plus 7 plus 13 plus 31 and all the way up to Tn. Subtract. S minus S, 0. 5 minus 0, 5. Then we have 2 plus 6 plus 18 plus 54 and all the way up to minus Tn. Now tell me how many terms? Now 2, 6, 18, 54, can you see? GP, but how many terms? Ma'am, again, from here till here, how many terms? 5 to Tn. Ma'am, from here to here, n terms. So this is n terms. But you know what? If you remove 5, na, then it will be n minus 1 terms. Okay. So eventually it is n minus 1 terms of GP. Okay. So Tn will come over here and this is 5 plus. Now sum of n minus 1 terms of GP. Sum of n terms of GP, tell me. Ma'am, A r power n minus 1 upon r minus 1. Okay, r minus 1. Now, A. What is A, ma'am? 2. R power n minus 1. 3 power. So, n minus 1. Minus 1. Because sum of n minus terms, right? Whole upon r minus 1. So, 3 minus 1, 2. 2 cancel. So, this is what? Tell me. Tn is what? 5 minus 1. 4 plus 3 power n minus 1 is nothing but your Tn. Once you get your Tn, just apply sigma to it. So Tn is 3 power n minus 1 plus 4, correct? Apply sigma. Sigma here, sigma here, sigma here. Okay. So now sigma 4 is going to be what? Plus 4n. And this is your Sn. Sn is going to be now sigma 3n minus 1. Okay, sigma 3 power n minus 1. So put n is equals to 1. So ma'am, I will get 1. N is equals to 2. So ma'am, 3 power 1. N is equals to 3 and all the way up to n. Last term will be what? Last term will be 3 power n minus 1. So Sn is going to be what? Tell me. Ma'am, again this is a geometric progression of n terms this time. Okay. So geometric progression of n terms, first term is a 3 power n minus 1 upon 2 plus 4n. So this is your Sn. Okay. Yes. Getting it? All right. Now, type 3. So, two types we have studied. Number one type is directly write general term by just observation. Okay. And the moment you wrote general term, apply sigma to it. Second one was method of difference, because in series, difference is in either AP or GP. Now, type third. Splitting the nth term as difference of 2. Okay. So, again, I will use a problem over here. So, see. 1 upon 1 dot 2 plus 1 upon 2 dot 3 plus 1 upon 3 dot 4 all the way up to n terms. This is actually telescopic series. Okay. Telescopic series. Telescopic series. Okay. Now in telescopic series, what do we do? And especially when denominator has two consecutive things. Okay. So you can just go on and write Tn. So ma'am, Tn is going to be n plus 1. Yes or no? Right? Now, understand this very nicely. This is very popular method. This I have taught you while teaching trigonometry series also. That whenever you see product of two things in denominator, always try to create difference of these two in numerator. N plus 1 and n. Always try to create difference in numerator. So, n plus 1 minus n whole upon n plus 1, like that. Okay, alright. Now n plus 1, see what did I do? Creating difference of these two things in numerator. And you know what? Even if you cancel n and n, eventually you will get 1 only. That means your expression value is not altered. It is not changed. Okay, so you are on right track. Now separate it. N plus 1 cancel 1 by n minus n cancel 1 upon n plus 1. Okay, Tn is equal to this. Tn is equals to this. Correct? Now, Tn is equals to this. Now, telescopic series. Tell me, what is the first term, ma'am? First term T1. T1 is going to be what? 1 upon 1 minus 1 by 2. What about T2? 1 by 2 minus 1 by 3. T3, 1 by 3 minus 1 by 4, and all the way up to Tn, which is 1 upon n minus 1 upon n plus 1. So 1 by 2 cancel, 1 by 3 cancel, 1 by 4 cancel, and eventually the moment you add everything, okay, see, you have to add everything. And the moment you add everything, tell me, only first term and last term is pending. So sum of n terms is going to be 1 upon 1 minus 1 upon n plus 1. So, n plus 1 minus 1 upon n plus 1. So, eventually n upon n plus 1 is nothing but the final answer. Getting it? Understanding it? Okie dokie? Yes? So, this is how it is. Okay? But now, if at all a little twist will be there in question. This was a very straightforward question, right? But now if at all you get any twist in some questions, right? Then what to do? Again, first write Tn. So ma'am, Tn is obvious. N plus 1, n plus 2 and n plus 3. That's it. Correct or not? Whenever you write Tn, please be double sure. Please be double sure by checking T2. If you put n is equals to 2, are you going to get this term? That means you are on a right track. Always check, especially when you are a beginner. 1 by 2, 3, 4, 5, ma'am. Yes, ma'am. T2 is also matching. T3 is also matching. So, yes, Tn I have written it correct. Do not doubt on me, ma'am. Okay. Yes. Now, what to do? Again, I told you, ma'am, difference you have to create in numerator. But now, ma'am, so many terms in the denominator. Which difference shall I create? So, now, n plus 3 and n. So, basically, the biggest term, n plus 3, and the smallest term is n. So, create the difference of these two. So, this is going to give you what? n plus 1, n plus 2, n plus 3, and in the numerator, you have to create difference of 2. The extreme right and extreme left. So, n plus 3 minus n. Now, you will be wondering, ma'am, how come? How come this 1, you are replacing it with n plus 3 minus n? Because this, if n and n you cancel, now 3 will be left out. So 3, how you have like 1 is equals to 3, that's what you are trying to say. No. Now because I know, I am aware, so 3 I am going to multiply it over here to compensate. Now tell me whether these two questions, whether these two expressions are same or not. Tell me that. Same, right? Pretty same, pretty much same, exactly same. So n by 3 upon the whole thing. So, n by 3, n plus 3, n plus 3 cancel. 1 upon 3, n plus 1, n plus 2. Minus. N cancel. So, 1 upon 3, n plus 1, n plus 2. That's it. Okie dokie, clear? Now, T1. Again, T1. Okay. So, T1 if you calculate, not here because telescopic series is going to get formed right now. So, let me just write it over here. T1. Tell me. Ma'am, T1 is going to be 1 by 3. Let's take 1 by 3 common. Let's take 1 by 3 common only, right? Now 1 by 3. 1, 2, 3. So, 1 upon 1, 2, 3 minus 2, 3, 4. T2 is going to be what? 1 by 3. 1 upon 2, 3, 4 minus 3, 4, 5, correct? And all the way up to Tn, which is like written right here. Okay, so now if you just start cancelling, 2, 3, 4, 2, 3, 4 cancel. So this is how it is going to get cancelled out. So this term will be left out and this term will be left out. 1 by 3 is outside. So tell me, Sn is going to be what, ma'am? 1 by 3. First term minus last term. So 1 upon 1, 2, 3 minus this. 1 upon n plus 1, n plus 2 and n plus 3. N plus 1, n plus 2, n plus 3. This is your Sn. This is your Sn. Correct? Now S infinity. So the moment you put n is equals to infinity, this will be vanished. So 1 by 3 into 1 by 6. S infinity is what? 1 upon 6 3s are 18. So 1 by 18 is absolutely correct. Yes, Harish? Yes, Harry Potter? Got it? Clear? Okay. Now one more question. Okay. Now I'll give you this question as a homework. Okay. But not exactly the homework, but I'm going to help you also. Okay. So again, write Tn. Try writing Tn now. I'll give it to you. Try writing Tn. Okay, so Tn 1, 2, 4, n, n plus 1, n plus 3 and n plus 2. Oops. Okay. Correct? So you know what? Here, can you see in the denominator, missing term is there. Agree or not? Because I can see that n plus 1, n plus 3. So what I'm going to do is, I need n plus 2 in the denominator. The sequence is getting disturbed. So n plus 1. Then n plus 2 I am going to introduce and n plus 3. And here n plus 2 was already there, just that square I am going to apply. So basically I have multiplied and divided both the things by n plus 2. Okay. So now n plus 2 square can be opened. So this is n square plus 4n plus 4 whole upon n plus 1, n plus 2, n plus 3. Correct? Okay. Now, let us separate the terms. Okay, let's separate the terms. N square upon this. So, Tn is going to be n square if it is gone. Na? So, n upon n plus 1. If, so n plus 4 upon. Hold on. Over here, do something. See, basically the agenda in such question is, you don't have to disturb the sequence. Here see 1, 2, 4. Sequence should not get disturbed. Okay. So make sure you do everything, but sequence should stay intact. Okay. Whether it is sequence of just 2 products, it is also fine. 3 products is also fine. Okay. So what I'm going to do is, tell me one thing, if this 4 can be written down as 3 plus 1. Why? Because see, n square plus 4n plus 3. So ma'am, it is n plus 1 and n plus 3. N plus 1 and n plus 3. So, okay. Alright. So yes. So this is n plus 1, n plus 3. Correct? Whole upon again n plus 1, n plus 2, n plus 3. Plus, now 1 upon whole thing, n plus 1, n plus 2, n plus 3. Good question by the way. Now n plus 1, n plus 3, the middle 2 terms got cancelled out. Okay. So now Tn is going to be what, ma'am? Tn is 1 upon n plus 4. Correct or not? n plus 1 and n plus 2 will be remaining. Yes, n plus 2. n plus 2 plus 1 upon again same n plus 1, n plus 2 and n plus 3. Correct or not? Yes. So I will treat. Now it is done. Now it is done because see, the numerator of both is 1 na? So we can deal with it. Okay. So I told you that in here you have to create a difference. So this 1 will be n plus 2 minus n, and obviously 2 will be for compensation because n plus 2 minus n will give you 2. So divide by 2 should also be done. And here this 1 will be replaced by extreme right minus extreme left. So n plus 3 minus n and 3 will be right here. So Tn is going to be what? Tn plus Tn dash. Okay, two types of things. Okay, here Tn will be what? 1 upon 2, 1 by n minus 1 upon n plus 2. Telescopic series, if you try to do it, T1 will be 1 by 2, 1 minus 1 by 3. T2 will be 1 by 2, 1 by 3 minus 1 by 5. So like this, things will get cancelled out. So sum will be what here? Sn will be what? Tell me. 1 by 2, 1 minus 1 upon n plus 2. Okay. Now, Tn dash. Tn dash. Okay. Tn dash means this one. So again 1 by 3, n plus 3 cancels. So 1 upon n, n plus 1, n plus 2. minus 1 upon n plus 1, n plus 2 and n plus 3. So clearly Sn dash will be what? 1 by 3. First term minus last, so 1 upon 1, 2, 3 minus 1 upon n plus 1, n plus 2, n plus 3. Okay, so this is Sn and this is Sn dash. If you add it, final sum will be this plus this. Okay, now let me just check. Sum of infinite terms is what they are talking about. Sum of n terms so I have calculated. Now sum of infinite terms. Sum of infinite terms will be what? 1 by 2 minus, sorry, plus 1 by 18. So S infinity will be what? 1 by 2 plus 1 by 18. That is going to be 10 by 18, 5 by 9. Okay, clear? Okay, clear. Now the next question or the next type altogether. Let's talk about the next type. Okay, the next type. Next type, which is 1, 2, 3, 4 plus 2, 3, 4, 5 plus 3, 4, 5, 6 all the way up to n terms. Correct? Okay. All the way up to n terms. So again, yes, obviously. Tn you can write, which is n, n plus 1, n plus 2, n plus 3. But you know what? If you multiply this, you are going to get Tn is equals to n power 4. Sigma n power 4 is something which you don't even know. So now for that, what you have to do is, you have to do something similar which you did in the previous thing, but slightly different. Whenever there was denominator, what we used to do is, we used to create the difference of two extreme terms in numerator. That's what we did, right? Extreme big and extreme small, just create a subtraction in the numerator. Let me show you. See, here what we were doing is, see, n plus 3 and n. We used to subtract these two terms in the numerator, okay? But in here where everything is in numerator, na, again you have to do same thing inside the bracket. But you know what? Don't subtract two extremes. No. What you have to do is, what is the extreme by the way? Ma'am, n plus 3. So just tell me what will be the next value, or one, like if at all n plus 3, if you go one step ahead or one term ahead of n plus 3, n plus 4 you will get, correct? Minus. Now what will be one term previous to it? One term after to this is n plus 4. One term previous to this is n minus 1. Just learn the technique. I know it is new, but learn the technique. Try to learn. Okay. So one term ahead of the bigger one and one term previous of the bigger one. Just do it in the bracket. If you do it n again cancel, and 4 minus 1, 5. 5. So 1 by 5. 1 by 5 for compensation. Okay. So Tn is going to be 1 by 5. And eventually n plus 1, n plus 2, n plus 3, n plus 4. Minus n minus 1 will be the first term. Then n plus 1, n plus 2 and n plus 3. That's it. If you multiply n minus 1 to all these things, okay? Okay. So this is your Tn. Now tell me T1. T1 will be what? 1 by 5. 1 by 5. So 1, 2, 3, 4, 5 minus. This is what? T1. If you put 1, this is 0. T2. Ma'am, 1 by 5. If you put 2, 2, 3, 4, 5, 6 minus. If you put 2 over here, so 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. That's it. So can you see that this term is getting cancelled out with this term? This term will getting cancelled out with this term. So if you add, what will happen? See, this term will get cancelled out. So sum of n terms will be what? Only this term will be pending, which is 1 by 5, n plus 1, n plus 2, n plus 3 and n plus 4. That's it. This is your Sn. Done, 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 done. Okay. This was the type number 4. Okay. Clear? Now, see, 2 questions will do. Okay, I'll give you hints only. Hints. And we are done with series based questions. See, JEE Main 2019. So, first term, second term. Actually, first and second term is not giving me the much idea. But third term is giving me the idea, and in fact, I can write Tn. So, Tn will be, see, this is 9, this is 12. Okay, so ma'am, 3 3s are 9, 3 4s are 12, 3 5s are 15. So, third term, this is third term, 3 3s are 9, 3 4s are 12, 3 5s are 15. So, ma'am, this is 3n. This is 3n. Now, third term is having what? 1 square plus 2 square. So, nth term will have n square. Whole upon 7, 9. So, if this is third term is 7. So, second term will be 5 and first term will be 3. So, ma'am, 2n plus 1. Now, check it out. Check it out. So, if you put 1, what will happen, ma'am? If I put 1, this is going to be just 1 square. This is just 3. 3 by 3. So, ma'am, first term is 1. Term 2, let's check. Term 2 should be 6, ma'am. Term 2. So, it is going to be 3 2s are 6. And this is what? Term 2. So, 2 2s are 4. 5. And 1 square plus 2 square. Because only 2 terms are. So, this is also 5. This is also 5. Cancel. Only 6. So, T2 is also matching. T3 will also match. T4 and so on. Correct? This is fine. Now, Tn is nothing but 3n. What about this? This is sigma n square. Direct formula. n plus 1 to n plus 1 by 6. Okay, and 3 1s are 3 2s are. So, Tn is going to be n square n plus 1 by 2. Okay, straight lines most probably after this chapter, once we are done with sequence and series. So, this is your Tn. So, what is Tn, ma'am? N cube. So, sigma n cube plus sigma n square by 2 is your Sn. So, Sn is going to be what? n plus 1 by 2 whole square plus n plus 1 to n plus 1 by 6 whole upon 2. Okay, whole upon 2. Done, done, done. So, now put 15, get the answer. Done and dusted. And now I am going to leave you with this question. See, this I have already done. A part. I think B part we have also done. C part also done. Now B part. B part will do. B part will do. So, Tn. Can anybody tell me Tn? Please write Tn very carefully. That's why I am not giving you complete homework, because I know most people will be like, ma'am, 3 na, n plus 2. Very wrong. You have to look for the series 3, 7, 11. 3, 7, 11. Just write 3, 7, 11. This is an arithmetic progression. Tn is what? A plus n minus 1 d. So, this is 4n minus 1. So, this is 1 upon 4n minus 1. 7, 11, 15. Okay. 7, 11, 15. So, 7. So, 4n plus 1. 4n plus 1. Correct. So, if you put n is equals to 1, 3. N is equals to 1 if you put right here. Wrong, wrong, wrong. 4n plus not 1. 4n plus C. It is going to be 7 minus 4. So, 4n plus 3. Yes. This is your Tn. Correct. And eventually what you have to do is now 4n plus 3 minus 4n minus 1. So, 4n plus 3 minus 4n minus 1. Subtraction of these two in the numerator. And eventually if you solve it, 4. So 1 by 4 is the answer. Okay. Yes. Tn is going to be, tell me, 1 by 4. And eventually 1 upon 4n minus 1 minus 1 upon 4n plus 3. That's it. Alright. This is your Tn. Now your homework that you have to, like, almost everything I have done. 4n plus 2 you are saying, huh? Wrong. 4n plus 3. That's why I'm telling you, writing Tn should be absolutely important, and always cross check whether you have written correct or not. Because you might write, okay ma'am, n plus 2 and n plus 6. Okay? Correct? Are you getting my point? Chalo. So we are done with series based problems. Also, you have to solve a couple of problems. Sequence and series JEE Main 2025 PYQs also I have solved completely. Okay. So make sure that you go and check that out also. For April and January attempt, you will find that session as well. Correct. And yes, Advanced Happy Teachers Day. It is so advanced. Why are you wishing me in very much advance? Come on 5th September. By the way, some surprises also there for you. Alright. So chalo, I am going to see you tomorrow. And also let me tell you that tomorrow I'll be dropping 99 subtopics that will ensure 99 percentile in JEE Main 2026. Okay. So yes. Tomorrow, and I'm working on it already, almost done. So tomorrow you will see that video, all the 99 topics, subtopics I would say, from mathematics. Okay. So this is me, your Ninja Ma'am, signing